Right, we have a question here, 5.2, that says simplify to a single term. Okay, we have given sine of 540 minus x and sine of negative x minus cos of 180 minus x times sine of 90 degrees minus plus x. All right, we need to reduce this into a single term. That's what the question says. To make it reduce to single term. Now, okay, here is the question, 5.2. Okay, I want to first start by drawing a circle here. Let's say this is a circle. Okay, maybe I'll try to make it more accurate. If I draw like one, I missed. Let's say this one. Let's say this is a circle. Yeah. Now, we do know that it's the trigonometric circles are split into 4 quadrants: 0 degrees, 90, 180, and 270, and back to 360 degrees. And then it's always like that: 360 degrees, a full revolution, 360 degrees, another 360 degrees, so on and so forth. Now, when we see over here 540, it means it completed the full revolution, 360 degrees, and plus something, okay, plus 180. So this is like, this can be reduced to something. I prefer to write this way. It's like 360 degrees plus 180 degrees, okay. Now minus x, okay. Now the following term, okay, trig term, is sine of negative x. We do know that the property says sine of the property says this: sine of negative theta equal to negative sine of theta. So this will be times negative sine x, okay. And now for the cos, now over here, negative cos of 180 minus x, I'm going to draw another circle here. Let's say this circle is for the cos function, the cos x. You look here, we do know that cos of 180 minus x is when it completes. It does, that's 90, but 180 is here. 180 minus x must be in the second quadrant. So 180 minus x is somewhere there. 180 minus x. So now we do know that cos is positive in the first and fourth quadrant. So meaning over here, cos is over here, cos is negative. So here, cos is just negative. Okay, so there I'm going to write minus cos x if I can reduce it. Now, sine of 90 degrees plus x, this is equivalent to cos of x. Okay, then we can work it out. You know, here we can reduce the angle already by 360 plus 180. We can reduce that because, as I said, over here, 360 means 360 is a full revolution, and then plus 180. So we can reduce it to 180. So this will be sine of 180 degrees minus x minus sine of x minus cos x squared. Okay, I prefer to, because let me write like this: cos squared x. Okay, and now sine of 180 minus x can be reduced to you know, I'm going to draw another circle here for sine. Okay, let's start with a circle. Okay, for sine 180 minus x, we still here in the second quadrant. So 180 minus x will be here in this quadrant. Now, in this quadrant, how is sun in this quadrant? Sun is positive in the second quadrant. Okay, sun is always is positive here and positive there. So here, sun is positive. So this will be sine, can be reduced to sine of x. Careful, this is not minus, but it's times negative sine. Okay, that's times the way times here. Times negative sine. So we have like sine times negative sine x minus cos squared x. Now sine times negative sine makes a negative sine squared x. Okay, I think over here, okay, it was, we say it's negative, right? So negative and the negative here will make a positive over here for the cos, yes. Here it's positive because cos, we say it was negative here in the second quadrant. So negative and that negative will make, all this makes negative cos x. So all this makes negative cos x. And now with this negative, then both make positive cos x. So the positive here. Positive and positive was what means that makes positive cos squared x. Now, what this can be written as cos squared x minus sine squared x. Now, remember something. The property says this cos of 2a or 2 theta equal to cos squared of theta minus sine squared of theta. So this is a double angle property. So we can reduce this into cos of 2x. So this is the final answer. We reduce these all expression into a single trigonometric term. Thank you.